this experiment, the students are expected to draw the valve timing diagram for a 4-stroke engine. So we have a cut section model of a 4-stroke diesel engine. So the 4-stroke engine, the entire cycle of operation is completed in 2 rotations of the crankshaft, and it has 4 individual strokes such as suction stroke, compression stroke, power stroke and exhaust stroke. So the purpose of this experiment is basically for the operation of the engine there are 2 valves. So one is the inlet valve and suction valve, another is the exhaust valve, and the purpose of the experiment is to find out at what instant these valves are opened and what instant the valves are closed. So when you study in the theory that the valves do open and close at the dead centers. So that means during the suction stroke, when the piston moves from the top dead center, the inlet valve will open at the top dead center when the piston starts moving from the TDC. Right? So this happens until the piston reaches the bottom dead center. So theoretically the inlet valve will open at the top dead center and closes at the bottom dead center. Similarly, the next stroke is a compression stroke. The piston moves from the bottom dead center to the top dead center. The third stroke is the exhaust stroke. Again the piston moves from the top dead center to the bottom dead center. And the fourth stroke is the exhaust stroke, where the piston moves from the bottom dead center to the top dead center. So we study that during the exhaust stroke, when the piston starts moving upwards, the exhaust valve opens at the bottom dead center and closes at the top dead center. But this is a theoretical the valve opening, but practically in order to get maximum performance of the engine, so the valves are opened and closed at more appropriate timings so that you are getting maximum efficiency from the engine. So that means the valves are not opened and closed at the dead center. They are opened or closed a few degrees before or after the dead centers. So that's what we want to find out, and we want to diagrammatically represent at what instant the valve is opening and what instant the valve is closing. And in addition to that, we also want to note down when the fuel is injected into the cycle, when the fuel injection. So here we have a cut section model of a diesel engine. So in the diesel engine, the air is compressed. Towards the end of the compression stroke, the fuel is injected. So we want to find out at which instant the fuel is injected and which instant the fuel injection is stopped. Right? So the first thing is we need to identify the top dead center and bottom dead center. So there is the flywheel. So the flywheels, there are reading scale is mounted where the various degrees are marked, right? So here as a cut section model we can directly see the engine as such. So looking from here you have to rotate this flywheel in the clockwise direction. So when it is rotated, see that here the piston reaches the topmost position. So here when the piston has reached the topmost position, this is my top dead center. So there is an indicator over here. Just make a mark and mention that, write that this is the TDC of the engine. So once TDC is marked, your BDC would be diagonally opposite to that. So that is after 180 degrees you find the BDC, or you can actually rotate this, and when the piston reaches the bottom dead center, then also you can mark that is your bottom dead center. So here now the piston has reached the bottom dead center. So again you can mark the bottom dead center here. So this is this indicator. You can mark your bottom dead center. So now you need to mark these the events, right? So basically, this is a 4-stroke engine observation table. I need to mark inlet valve opening, inlet valve closing, exhaust valve opening, exhaust valve closing, and fuel injection opening and fuel injection closing. So these are all the 6 events I need to mark. And I also need to mention this event is for this event, which is the nearest dead center. Whether this event is happening closer to the TDC or closer to the BDC, that I need to write, and I need to mention what is the angle with respect to the dead center, how many degrees. So that also I can measure it in this graduated scale, and from that I can measure it and I can mention it. And also I should write whether this event is happening before or after the dead center. Okay, this is the first is inlet valve. So you need to identify your valves, which is inlet valve and which is exhaust valve. So coming over here, so this is my the air filter, right? So this is my inlet manifold, right? And this is going to my inlet valve. So this is my inlet valve, and so this is the silencer. So this one is the silencer or the muffler. So the one which is connected here is corresponding to that. So that is my exhaust valve. So my exhaust valve is here. So this is my exhaust valve. So once you identify your, so this is my the inlet valve. So that means the other one is going to be my exhaust valve, right? So first you need to find out the inlet valve opening. So basically these valves are opened with the help of a cam and rockram mechanism. So this is basically, you have the camshaft, right? So this is the camshaft of, this is the camshaft, right? So on the camshaft there are cams are there. So I have a cam for inlet valve and a cam for an exhaust valve, and so there is a separate cam for opening and closing the fuel injection nozzles, right? So as the crankshaft is rotated, the camshaft is also rotated. Basically the camshaft and the crankshafts are connected by the timing gears, and if you see the size of the gear, it will be twice as big as that of this, so that the speed of the camshaft would be half the speed of the crankshaft. So that means when the crankshaft rotates to rotation, one cycle is completed. During that time my camshaft will undergo one rotation. That means one cycle will be completely rotated, right? Finished. So and from the camshaft I have this, this is called the push rod, and on the top of the push rod I have the rock rams are there. So as the cam moves and as the camshaft rotates, so the push rod moves upwards, and the rocker arm, the upward movement of the push rod causes the rocker arm to move downwards, which pushes. So this is the valve tappet and the springs over there. So this end of the rocker arm pushes the spring downwards and the valve is getting open, right? So basically when you want to open the mark the valve opening, now we are just rotating. When I am rotating, so when this just begins to move down, when you just notice the movement, so that point I just mark it as the inlet valve opening. So now you can see that. So here this compression is happening. Yeah. So now as the piston is coming downwards, right, my inlet valve is opening. Now the suction stroke is happening. So I am just rotating clockwise, and I see that here the valve is, the movement starts. So that means the valve is getting opened. Or in another way, you can just observe the movement of the rocker arm also. When the rocker arm just goes down, so that time also, so actually this end will move up, right? So you can come back and you can just note here when, now it has started upwards. So that means this goes up and this side goes down, my valve is going down. So by seeing this also you can make the inlet valve is opening. So corresponding to the marker, you mark a point and mention that it is IV hook, right? So then on further rotation, right, I see that this valve is in continuous opening position, right? So now it is in the completely open position, right? But by the time the compression is also started, the valve is also, now it starts moving, it starts closing, right? So when this has completely closed, right? We just close it.